Hello friends, today we discuss how to present a differential equation model in LabVIEW. For that purpose, I have a second order differential function. As you see, d square y of t divided by d square. Here y is a function which depends on time. Let's say t is the time, plus 3 dy by dy of t divided by dt plus 2y of t is equal to 3ft. And here ft is a forcing function, or you say force. So we can solve this equation by two ways. First one, by using this, like as you see over here, the second order equation. Second order part is on the left side and this one is on the right side. So minus 3y dy by dt minus 2y plus 3f. So this is my equation. Now you have to just integrate to solve this equation, or to solve the y in this equation you have to double integrate this function. So for that purpose I just go to my LabVIEW block diagram window, as you see over here, Control T. So over here in the control and simulation, you have to install this toolbox in your system, control and simulation toolbox, before attempting this. So I go to simulation, and over here I have a control and simulation loop in this function. So I just drag and drop this. Then I just again go to this function, I lock it. In the signal generation, I just use a simple step signal, as you see. Now I just use gain. Over here this is my gain. Okay, and you can configure it also if you want to change the gain value in real time. So I just make it terminal. So just connect it, and over here as you see, when I put Control H, the gain terminal is over there. Just remove the label. So label is gone. Create control. So over here this is my gain. Then you have to use summation block, because we have to sum up, and in this case I need 3 summation. So as you see how I change this, you have to just click, like right now it is minus, just click on it, right now it is plus. So now as you see in the differential equation, we have to add these functions. Okay, so for that purpose I am just using integrator. In the continuous linear system I got linear, so I just use one integrator over here, and I just copy again this integrator over here. Now you have to just multiply this function. So I just copy this gain, just delete this and change reverse the terminal. I just delete this and copy this function. So now just connect this So over here, integration, it will perform integration. Now you have to just put this over here and sum this. Again you have to, over here you have to just drag and drop the function in the control and simulation in the graph and utilities. Over here this is sine wave graph. Connect this, and this function comes from here to over here. Okay, so this is how we can create a equation. Let's say over here this is my d square y divided by dt. Now after integration it will becomes dy by dt, and again after integration it will becomes y. So over here we get the value. So right now I just create control for this, again create control for this. So these are my gain. Now I just minimize the space, control U, control U. So my system becomes like this, and over here this is my gain. These are the different values. So I have to put these values from the equation. So right now, as you see, from here in the differential equation we have to put 3f minus 2 and minus 3. So this value is my 3, this value, that is gain 2, this is minus 3, and this value is minus 2. So I just put on the same order. On the same order, like minus 3, minus 2, 3. So minus 3, minus 2 and 3. Okay, so when you hit on run button, as you see, you can check out the result. It will take some time. As you see, the response is there. So when on the alternate way, when I just use a transfer function, so in the control and simulation, again go to control and simulation. Over here in the non-linear part, not linear, continuous linear part, we have a transfer function. So as you see, in this case you can solve using this way, using integration, or you can directly use this transfer function. This transfer function comes from this equation with the initial condition 0. It is the Laplace transform of this part. So I just put this part in this function. So I just put 3, as you see, 3 divided by 2 plus 3, it is 3, it is 2. So let's check, it is different. So 2 and over here 1. So as you see, 3 over s square plus 3s plus 2, 3 over s square plus 2s 3s plus 2. So I got this function. So you have to apply your input signal. Let's say it is simple step signal, and I am just drag and drop this value over here. I'm just clearing the graph, clear the chart. It is in data operation, so just connect this. So when you hit on run button, you can check out the result in both the graphs. So over here, as you see the difference. So when I put, this is my gain, it is 3, it is 3f. Okay, so over here, let's say I put -2 in this and -3 in this, and check out the result, it is same. So -2 and -3. So as you see in the real time also, let's say I am make it continuous run. So when I increase the gain, you can check out the result in real time also, how differential equation behaves. So over here, this is the same response, it is the same transfer function. Right now the transfer function of this and transfer function of this part is same, as you see. So this is how you can create your differential equation in LabVIEW using control and simulation toolbox. Thank you.